Okay, here we got a video trainer. We're going to wire up item by item. This is a trainer board, 24 volts AC transformer circuit with an overload. So we're going to go ahead and wire this particular diagram up. The blue lines are representing 120 volts. The orange / red lines, green lines are representing my 24 volts, positive, negative. My reddish orange lines here are my power, and my green is my neutral. I'm using a contactor that's 24 volts AC, a relay that's 24 volts AC, two indicator lights at 120 volts. That would be powered up by our R1 relay up here. We have a 24 volt time delay. We're using a switch. We're going to have circuit breakers as a switch, and then our fuse. Looking here at the training board, we have a 120 volt primary, 24 volt secondary transformer. I have my 120 volt primary already connected to the terminal blocks. I have the secondary side on terminals 2 and 3 already connected to the terminal block. We have our incoming power coming in through our fuse, out of the fuse, powering at the terminal block. We're using circuit breakers and acting as switches. That way they fed onto the DIN rail faster and easier. We are using a 120 volt time delay relay. This is a 20 volt delay on make and delay on break. This is two 120 volt double pull, double throw relays we're using. These are spare terminal blocks because in motor controls we do not use wire nuts for connection points. So these are spare terminal blocks should we need them for future diagrams and wiring that we'll be doing. Up the top here we have another set of terminal blocks, 6 and 7. They have a jumper screw between the two of them. So that's why we have two 6s, two 7s. We have a 120 volt contactor. We have an overload block. It doesn't matter what the neutral voltage is. It's just going to be an overload block. We have a 24 volt double pull, double throw relay. And we have another set of terminal blocks, 8, 9, and 9 jumper together, and 10 for our indicator lights that are already wired up. For the sake of the contactor, we're going to introduce a magnetic contactor. I've already had the connectors points for those. And we're going to utilize a 24 volt time delay on make relay. This one is different from this, where this one does not need a coil to start timing out. Once the input voltage is applied, our timer is set, and the load on here will energize, allowing the transfer. One of the things, it's always a good idea when you're wiring up some of the trainers is to take a highlighter and go over your drawings. That way if there's any questions on what did I wire and I didn't wire, at least you'll have a highlighter to indicate that. Our first set of wiring is already showing a wire from terminal 1 going up to terminal 6. So if I look at my drawing here, we can go ahead and don't have to run new wires. We know that wire 1 is connected already to wire 6. So, and my wire 6 is already connected to our transformer. Even though it's not connected to 6 up here, we have it double lugged on 1. So, small technicality as far as the description goes. It was easier to put the wiring down here than it is back up there, because on the future diagrams, we're going to be using terminal 6 more in either room. So, what we can do is now that we already have the transformer connected, we don't need to do any additional wiring here with this. We can go from terminal 6, follow it around to our common of our 24 volt relay. So I'm going to take my jumper wire. I'm going to go from terminal 6 This particular one, I'm going to start on the back side of this terminal. When you put your wiring in your terminals, you always want to do like a tug test to make sure it's in there snug. It's not coming loose. It's going to go into the common side of our relay. Now, if you're not familiar with which one is a common on the relay, we're going to take our meter, make sure it's on resistance, and I can check the bottom two terminals. I get no resistance. Going across the top two terminals, I'm getting 148 ohms of resistance. If I go to the back terminals, not showing any resistance. Move hand out of the way, not showing resistance. If I go across the bottom one, it's not showing resistance. But since I have my meter leads out, and I know that my front two coils, I'm getting 148 ohms, which is telling me this is the coil. So if your coil terminals are on one side, 90% of the time on dual purpose relays, your common contacts will be close conjunction to your coil. So if I turn one on here and I start on my other side of my terminal, I'm getting 0.3 ohms of resistance. So that's telling me this is my common, this is my normally closed contact. And if I go straight down on the same common, I got to open, closed, normally open, normally closed, normally open. Since I had my meter out, I know that's my connection point. So according to my diagram, I want to go from 6 to my common, which is going to be here on the bottom. And tighten that down, pull on it, and now I am going to be able to highlight this, saying that I've already gone to my common terminal. Now, since we're on board with this, let's go from our normally closed and our normally open terminals to terminals 8 and 10. Because my normally open terminals on the back, I'm going to do that one first. So my normally open one is going to connect it to terminal 10. I'm going to land that wire. And you can see I'm just going to curl this around those lights. So I'm troubleshooting. It's not a big spaghetti mess. Now I got that wire in. Let me connect my normally closed wire. Follow that around to my terminal 8 wire. I'll tuck that away in so it looks clean and neat. Now I have these two connections. We've already said these connections are made for us. So that's that. So we have, according to our schematic here, looks like we already have all our highlights. We can tell right off the bat where we're at. So now we just need to connect from wire terminal 2 to our switch down here. So grab this one. I'm going to apply this to terminal 2. And it's going to go into, I'm going to tuck it around here into the front, into terminal 6. So I'm going to go here, or to our switch. From our switch, after switches makes, we're going to go through, our switch closes. We're going to go through here to our time delay. Time delay already has a couple tabs up here. So we're going to land the wires. Landing is also called connecting our wires to the back of here. Now these are not the best conditions. So like I said, we're just going to kind of leave it there, making sure it's in a nice spot. So we already have this wire. Now we have to leave the time delay to our relay. One of the problems we have here, I just connected this to our load. We want it to be on our input. So I'm going to take this one back off and connect it back to my input. We got to make sure that when we have 24 volts coming in, the time process will start timing out. So now I have a wire here connected. I'm going to grab a different color wire, connect it to my output. Connected on my output here is going to go into my coil of my relay. Now it doesn't matter which side we're going to attach the wire to the coil, as long as we have a connection. So right now, get that kind of wrapped around there for now. So again, this is for training purposes. It's not something you would do in the field. We have our wire, our time delay input, and our output is going into our relay. Now, we do not have our neutral and relay connected yet, and I'll explain why. The next one I'm going to connect is number 2. Come to our power source, into our power source. So every time the transformer comes on, our overload here, our contactor, is going to power up on our coil. So if I take my wire here from my contactor, my relay, my contactor. If I take my wire from my contactor, I have to come to power source 2. So what I'm going to be doing here, because you can see, is we already have one terminal block coming here, even though it's written on the drawing is to come off 2, they're saying a splice point. We don't do splices on trainer boards. That's why we have terminal blocks. I can try to fit this wire onto here. It's going to be a little cumbersome. I know I have more room on this side, and right now this is my primary side coming in. So instead, I'm going to jump over here real quick and coming off the switch. So I have more room on the back side of my switch than I do on my terminal block, because the pins we have here, diameter with these terminal blocks, usually made for 1 pin, a little harder on 2 pins. So even though I'm modifying the same concept, I'm sticking 24 volts from here into my transformer, or my coil, or my contactor. So I have that connected, and I know my transformer is already pre-connected here on the secondary side, so that's connected. Now I have to take my neutral out of the contactor into my overload. Now here is my overload, and you can see this one does not have a DIN rail on the bottom of it, so for this particular one I have to lay it in place. So the question is, we want to make sure that we get our normally closed contacts. So while our motor is still on ohms, we're going to, using the 4 different terminals, usually ones are grouped together, or one set of contacts, open or closed, and the other ones are the opposite. So I'm going to have to determine, placing my meter on the bottom contacts. Is it this one is normally closed? No. Or is this one normally closed? I have continuity through the meter. Overload is here. I do not have continuity through there. Before I put my wiring connections together, you can look on the side of your overloads. That will tell you the contacts. It tells me 95 and 96 here are normally closed, and 97 and 98 are normally open. And then it kind of gives you a set of contacts on the bottom. 95, 96 are closed, 97, 98 are open. If I look at this on the bottom here, it says 95 and 96. Those are the two terminals I did not get continuity on. I did get them on 97 and 98. If I look on the side here again, 97 and 98 are supposed to be open, not closed. Again, that's normally open. 95, 96 are supposed to be normally closed. They were shown open, so I'm showing opposite of what I have. Do I have a bad overload? Or looking here is I have a red orange indicator light. That is telling me that the overload is tripped. If I hit the reset button, it clears away. So before I determine which contacts I have, make sure it's not in the trip position before you check it out. It's in the reset position, normal position, and our contacts are changed. Let me come back and check my contacts again. My bottom contacts were open. Now they're showing closed. And if I go up to the top, they're now showing open. So I've got to make sure that as I leave my coil here, I'm going to go into, I'm going to use this bottom one. And again, doesn't matter which one, doesn't matter if it's 95 or 96 first. I'm going to go into the bottom one and connect my neutral wire into my bottom contact. And your particular ones, this will be fastened to the board. Again, this is the only one I have that doesn't have the connection point on it, so I'm just holding it for reference for you. I'm going to take another wire out of there, and I'm going to leave 96. I originally connected 95. You can look on your own block. Connect that here. It's going to go to my relay coil. So if you look at your schematic, this little wire here, this very little set of wires right here is the only connection point we just made. It looks small on the schematic, a little bit bigger out here in the field. Now, and we made this connection here, from here, back to relay. So we went to 95, 96 to our relay, and now the relay, we have to make a wire coming back to terminal number 3. So let me grab from here. We know our blue wire was our coil. We're going to unscrew this terminal, and then we're going to put 2 terminals in here. 2 pin connectors with wires on them. Our connector here. I was so confused for a minute. I'm going to go into terminal 3 on the bottom here. Let me move this around just a little bit. As you can see, after a while, the amount of wiring gets a little bit cumbersome to test everything out. So now I have my overload block. I have relay 1 coming down, terminal 3, and then we know our transformer is already connected to terminal 3. So now as you look at all this, you see highlighters over every part. We know we're going from our fuse, this blue wire down here, goes into terminal 1. So if you want to, we know this is not there. This is an old switch from previous. We didn't have that particular one to control the power to it. So we have power coming in. It's going to travel around through our terminals, our contactors, relays, and so forth. Since you've highlighted the wiring as you went along, and you have your loose wiring here, as you can see, it just kind of wants to float per se. You try to find a spot for this to settle down so we can adjust it as necessary. So everything should be connected already. Our meter's set on ohms. Before I like to do anything, I put my meter on voltage so that way I'm not quickly checking something when it's on resistance and possibly have a fuse go bad. Now all I have to do is power up the meter or the trainer, and we'll see what happens. As soon as I power the trainer up, my contactor here, you heard it click, just closed. To verify that, looking at the schematic, I know terminal 3 is my negative for 24 volts. If I check that across my contactor, I'm getting power. So I know from terminal 3, power is going to 2, into my switch, into the switch here for the contactor. We have it come in here, always getting power. So nothing, unless I break power here, nothing is going to turn off C1. If I follow my wire along here, C1 is always going to get power as long as I have power to my transformer. And then we should have power to our primary side of our switch here, which we do. If we check on the other side of a switch, we do not have power. So I have power to this point, I do not have power here. If I close my switch here, checking from 3 to my switch now has power. So that means I should have power going to my input of my time delay relay. And I'll check over here to my input, and I have power. Now do I have power on my output? Now I do. I didn't for a second there, but I have my time delay set up differently. So once I do my time delay, I'm going to energize my relay, and that's going to change the state of my light. So telling me that when the relay coil is energized, my contacts here are going to change. So my nearly open are going to close, powering up my red light, which is on now, versus my green light. Okay. If I was to want to check my circuit again, I'm going to power down, open my switch. You see here the green light is on, not the red light, because I have a time delay. I'm going to adjust my time delay just a little bit higher. I'm going to reclose my switch. Now, if I wanted to verify my time delay is working, I'm going to check input power. I have input power, and I have no output power. So when I have output power, we're going to switch from a red light, green light, to a red light. A red light will energize, my green light will de-energize based on my time delay. I'll give it a few minutes here because I made some adjustments on my time delay on make here. We'll wait. As you can see on the trainer board, is once you have a lot of wiring, I use different color wiring just to make it easier for identification, for troubleshooting purposes. And you can notice on here, a little more cumbersome as you start having some stuff wiring together. If we had the 24 volts and the 120 volts all connected, you can see in a small physical location, it gets even a little more impacted. Now my time delay just timed out. My lights had changed status, and my coil here is now energized. If I check my across my meter, my coil's energized. My contacts here, coil's energized, contacts here, and my coil is still energized because my contactor's pulled in, because as soon as I apply power to my transformer, my coil pulls in. Now let's test out, we test our relay. With our time delay, we know that this circuit works fine. We can turn that off. So we know this circuit here has nothing to do with our contactor. The only way we get our contactor to change state is go through our overload. So we want to pull up on our overload. I'm going to go ahead and check my overload. I have 0 voltage across my coil because my overload is tripped. And to verify that, I'm going to put my meter leads in my neutral again. I'm going to check it across my terminals. I'm getting 26 volts to terminal 95, and I'm getting 0 voltage to 96. And again, I'm coming from my neutral terminal, or my positive terminal, I should say. Positive to 95, getting power. Positive, 96, no power. I'll check it again from my neutral to 96. I'm getting voltage. Neutral to 95. I'm getting no power. So again, this is the wires coming back up. Wires coming back through our lead here. Our contactor now is open. I'm going to go ahead and reset the other way here. I'm going to reset, and you're going to watch this guy here. You watch it pull in once I push this down. This guy pulled in. You heard the click. And now my overload is working. So we know our overload protecting our contactor here is opening. We know that the wiring is, the coil of our C1 is always hot if we have 24-volt transformer. We tested our time delay relay. If we energize our time delay relay and delay on make, we have a green light, no red light. And then once our time delay times out, it will change from a green to a red. As soon as you adjust your time delay, you can adjust it as high as you want, as long as you want. It's entirely up to you to get the setting that you want to get for that. This one's set a little longer. Let me see if I can just adjust it down just a little bit while it's still timing. Still showing a green indicator light versus a red. And right now we want to wait for the time delay off. Or time delay on make, the time delay to finish timing out, to close the relay contacts for our set here. We just had a change. My relay came on and my red light indicator here came on. A little harder to see it, and the lights we have, you can kind of get a general idea. The green went off and red came on. So that's the board that we have here. This is the training we have set up. You will wire up trainer board 24 volt transformer circuit with overload. And the overload is only protecting the contactor. The relay will switch the lights back and forth using a 24 volt time delay setup with all the training. You see the wiring here can get cumbersome. That's why it's easier to use a highlighter to review the lights you have and go from there. Thank you. Have a good day.